In this video, we have a graph that will be a curve, and we'll see how that happens by studying our pattern, completing the table of values, graphing our set of data, then we'll describe the graph and come up with an equation. So one step at a time. Our pattern, based on the figure configuration, is first we have figure 0, which is 4 squares. Figure 1 is 5. Figure 2, if we count, we have 8. Figure 3, we have a square on the inside that is getting larger and larger, and noticing that the 4 corners are the same. So figure 3, 13, 9 is the square on the inside, and then 10, 11, 12, 13. Figure 4 is again a square, and that's a keyword for the pattern. So it's a square 4 by 4, which is 16, and then plus the 4 corners will be 20. So 16, 17, 18, 19, 20. Then following that pattern, we need to figure out how many little units will be figure number 5. So we'll get there in a little bit. By looking at this pattern, it's not a simple adding the same number pattern anymore. So we need to observe something different. And if I graph, we have figure 0, 4 squares, figure 1, 5 squares, figure 2, 8 squares, figure 3, 8, 9, 10, 11, 12, 13 squares, and figure 4, 20 squares. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. It's not a constant rate of change, so it's not a straight line. This one shapes up as a curve. So it is not a linear growth because it's not a line. Curve. If you think of curves, that is exponential growth. So something will have to do with multiplication or exponent. So linear growth is for constant rate of change when you just plus or add a certain number, like we did in the previous lesson. And we had that slope, which is constant, and it created a straight line. This one has to do with curves, which is related to exponential growth and multiplication. So let's analyze that pattern or study the pattern a little bit deeper. First figure, which is called number 1, had 5 squares, but then we have to back up to figure 0. Figure 0 is important because that's the y-intercept. So in the equation, that is the starting point or the y-intercept on the graph. So if figure 0 is not given, we always want to go back and draw it to see what the starting point is. Then, starting with figure 1, we have 1 square in the middle and then plus the 4 corners. Figure 2, there are 2 by 2 square. 2 by 2 square is a 4 unit, big square, 1, 2, 3, 4. And then plus 4, the 4 corners creates an 8. Figure number 3 is a 3 by 3 square. So a square multiplied by itself, 3 by 3, creates 9 square units. And then plus 1, 2, 3, 4 as 13. Figure number 4 is a 4 by 4 square. 4 by 4 square, or 4 times 4, creates 16 units. 17, 18, 19, 20 is the number of tiles at the end. So that pattern is really important to connect the figure number with the square on the inside, and the only number that is consistent from figure to figure is the +4, or the 4 units that is added to each figure. So to describe the pattern, we can say that the figure number squared or multiplied by itself I'll put in parentheses, or multiplied by itself plus 4 corner tiles. So based on my pattern, what I noticed is that the figure number squared, so let's check that. Figure number 0, 0 plus 0 times 0 multiplied by itself is 0, and then the plus 4. So that would be 4. Figure number 1 multiplied by itself. 1 times 1 is 1, plus 4 is 5. Figure number 2 multiplied by itself. 2 times 2 is 4, plus 4 corner units, that's 8. Figure number 3. 3 times 3 multiplied by itself or squared is 9. 9 plus 4 is 13. Figure number 4, that would be 4 times 4 is 16, and then plus the 4 corner units will be 20. So what should be then figure number 5? Figure number 5 will be 5 times 5, which is 25, and then plus 4 corner units should be 29. So to observe the pattern, you always have to make sure that after you observe it, you test it to make sure that it works for every single number of tiles in the figure. Once you checked that, you can find the number of tiles in any figure. We'll see that in a little bit one more time. So to describe this graph is a visual interpretation. How does it look like? So describing graph means how does that actually look like, and just kind of include some of the details for reference, such as I can say that this graph is an increasing curve. So it is going up, and it is a curve. So it's not a straight line. So I'm just visually describing how this graph looks like. So the graph is an increasing curve that starts at the y-intercept zero 4. That's why it's important to know where that or how many tiles is the figure 0, because that is the y-intercept starting point on the graph. So that's called y-intercept 0, 4. And we can say and has only positive values. So we can include as many details as we can, but for the keywords, we need to mention that it's a curve and the y-intercept. Those will be the main key details. This one has only positive values because we don't have negative figures, so we can say figure -1. So that is not something that we are interested in. And for that, x squared, or a number multiplied by itself, will be always positive. So it has only positive values. For the equation is our observation of the rule that worked. For every figure, we multiplied by itself and then added that 4 that was constant number of tiles. So what I'm going to say is y for the function or the y values depend on x, where x is the figure number, so I'm going to say x squared or multiplied by itself, and then plus 4 will be the number of the four corners that were consistent in each figure. So every y value, which is the number of tiles, is calculated by multiplying the figure number by itself and then plus 4. So for example, what if I ask a question? What is the number of tiles? So here is going to be an extra question. How many tiles will be in figure number 10, let's say? So how many tiles will be in figure number 10? So instead of drawing all the way to figure number 10, using this rule, we're going to say, well, in y10, or the function of 10, figure number 10, we're going to have the figure number 10 squared plus 4. And that would be 100. 10 times 10 plus 4, 104. When we observe the pattern and we see the visual interpretation, we can come up with the rule. Remember, before you use the rule, you test it. So once you come up with the rule, y equals x squared plus 4, let's say, you test it for all the values in the table to make sure that your rule works. After that, you can answer any question about the number of tiles in any figure that is being asked.